Assalamu alaikum. So I have made a simple function here. So this is my original signal and it is shifted. This original signal is shifted here and the original signal has been folded here. So I have done two things. One is shift and another is fold, and to do this I have made two functions. One is signal shift and another is signal fold, and I have to use this for the next lessons when I will do some convolution or I will do some autocorrelation in this digital signal processing video playlist. So let's start. So let's first talk about the theory. Signal shift. Okay, so what is in my main function? Let's see. So in my main function I have two signals, and let me draw this signal. So this is the signal. So this is the signal which starts from -2 and ends at +3. So the signal looks like this. Okay, -2, -1, 0, 1, 2, 3. And now I want to shift this signal by k. Then I want to shift this signal by k. That means, let me draw it with the red line. That means this value will be shifted here, right? And initially it was at 0 position and now it will be at a k position. And not only this value, all the values will be shifted by k. Okay, that means this is -2 plus k, -1 plus k, then this k, I mean it's 0 plus k, then 1 plus k, 2 plus k, 3 plus k. So what I have to write in my code, so this is my code. So you see that the values of the signals are same, right? My original x was 1, 2, 3, 4, 5, 6, and my x shifted. My x shifted is also 1, 2, 3, 4, 5, 6. That means I have to copy the values of x to the x shifted. So as the values are same, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I have just copied this value of this x to the x shifted, but my time index has been changed, right? Here my time index was n, and now my time index is n shift. So let me see what is n. So n is -2, -1, 0, 1, 2, 3, and n shifted is -2 plus k, -1 plus k, 0 plus k, 1 plus k, 2 plus k, 3 plus k. That means now I have to get n shifted, I need to add a k with n, and if I do this thing I will get a new time index. So let's see what is in my video, in my code. So first of all I have so first of all I have defined the signal, and then I have plot this signal. So if I plot the original signal, it looks like this. Okay, and now let's say I want to shift it, and let me pass the value of original signal is time index, and let's say I want to first shift it by 4, and let's pass this information to the signal shift function. So this my signal shift function, it will receive original signal, time index, and k, and then it will just copy the values, but it will just add k with the time index, and then it will send the shifted x and n. And if I go to the main function, then plot n shifted and x shifted, let's see what happens. So wait, this is my original signal and this is my what's happening. Okay, this is my original signal, and this, I don't know what's happening. Okay, so this is my original signal and this is my main signal, but I don't know why this is not coming. Okay, oh, this is my original signal, and if I run this, so this is my main signal. It appears here, sorry for the confusion. Okay, and you see this shifted by 4. When this value was at 0, now this value is at 4. This value was 2, and now at 4 this value is what's happening. Oh, at 0 the value was 3, now at 4 the value is 3. Okay, my code works well. If k is, let's say, -4, now let's see what happens. So my signal has been shifted to the left. Okay, that's an easy function. Now let's talk about the xfold. Now I have passed the original signal and n to the signal fold function, then it receives x and n and do this operation. Let's see what is this function doing. So let's say I have a simple original signal. So this original signal, let's say, looks like this. Let's say this signal looks like this, and now I want to find the xfold. That means I want to find x minus n. So now this signal will look like this. Okay, so the value and the index both has been changed. So let me write the code here. Let's say what is x. X is, okay, let me write it here. X is, let's say, 1, then 2, then 3, then 4. I mean this value is 1, then 2, then 3, then 4. And now the x fold is equal to 4, then 3, then 2, then 1. That means this matrix, this row matrix, has been folded. So I have to flip it. So I have to use a built-in function now, so which is flip LR, flipped left right. And if I use this function, then this function will make this row matrix into this. Okay, so now my time index has been also changed. Now my new time index is, let's say, n fold. And what is actually n fold? If you see that this n starts from -1 and ends at 2, but n fold starts from -2 and ends at 1. So let me write that thing. N is equal to -1 0 1 2, but n fold is equal to -2 -1 0 1. That means if you, that means let me write it here. N fold is equal to -2 -1 0 1. Okay, that means if you make flip LR and then write it n, if you use this function, what this function will do? So this function will make 2 1 0 -1. And now if you want to change this matrix into this matrix, you just need to multiply a -1 and then you will get this matrix. So just multiply a minus here, and if you do this, you will get n fold. Okay, so let me go to the code. So you see x fold is simply flip LR, but n fold, you have a minus here. So you have to put a minus here, then go to the main signal, main function, and let me run this code and let's see what happens. Okay, the signal has been, this is my original signal and this is the folded signal. Okay, now let's do another thing. Let's see it works or not. So I will do now two things at the moment. Now I will shift then fold. Okay, so first I will shift by 4 amount and then I will fold, and let's see what happens. So shift and fold, let's see what happens. So signal, first I want to fold, so signal fold x comma end, and then I will shift the signal. I will apply signal shift, and I want to shift it by, let's say, 4 or 2, let's say. Now let's see what happens. This code is not running. Okay, I understand I can't write like this. Okay, no problem. Let's do first signal fold x comma n and make it x new or x folded, n folded, and then I want the final output, let's say y and ny, which is which is equal to signal shift xf nf, and I want to shift it by 4, and let's plot, let's make a new figure and plot subplot 211 stem. Let me plot the original signal and then let me plot the output signal. So stem ny comma y. Okay, let's see. Okay, and let me set the x limit. So x lim is from -10 to +10, and also here x lim is -10 to +10. Okay, let's see. Okay, so this signal has been shifted. Let me shift it by 5, then it will be visualized well. Okay, so this signal has been first folded and then it's shifted, so we can do this, and it's used in convolution, right? In convolution we have to first fold their signal and then we have to shift their signal to make the convolution. So these two functions will be needed in the convolution, so that's why I have shown this thing. Okay, thank you.